fat as COVID.
You're like a fed in the, you're like a fed hitting the wall. You trying to go through the walls.
Oh my God.
I wonder if you can on multiple restaurants. Or you like type. They're like, yeah, we keep you have a bunch of sandwiches disappear.
So I have to get my nails done.
All right. All right, questions.
What power?
Continuous independent variables. I just uploaded the. It works.
Yay.
I don't think anyone said that.
I have an issue. None of my chunks have a little thing where I can run them. Does that make sense?
Yes. None of your chunks.
Mine didn't
Whenever
highlight it,
See what it looks
so.
like.
Like it has it up here that I can write, but like no. I already closed mine.
Already going through that?
Yeah.
My one?
I'm gonna share with you because I can't get yourself.
Oh, secrets.
I have hearing.
I don't get that.
What?
I don't get that.
I watched the blue people one, the ball one. Yeah. Well, the little ball play was kind of deep. I just got blue people.
Not turn in here though. I'll send it.
Someone has blue, so you
Is it grilling?
Dude, it's in. I seasoned it yesterday.
How do you see it? Just let it smoke for a long time?
Yeah, you just do like 1 3-hour smoke, nothing in it.
That's my father-in-law with chips and uses pellets. And he said he has a blend. It's just got a ton of different. What else say you got?
You got a trade
on.
Yes. What'd you get again? Masterville?
Masterville, yeah.
I ain't got my.
Is
Is it a pellet grill?
Huh?
Pellet grill?
It's an electric smoker.
Yeah, so it's a pellet one?
Yeah. I'm not like,
I don't know.
really well
Let me
versed
look it
in
up.
this topic.
Fair enough.
Buy you some ribs yet?
I think we've seen it before.
Yeah,
I think we've seen it before. So flip this up.
I was really hoping last week.
That's it. R markdown.
I was tonight.
Chunk does not show.
They did chicken on his last.
Mine's still on.
You did it for 12 minutes.
Probably how many random
That's
positions?
really
Yeah,
fast.
10,000. And how
Well,
many
once
of them
ago.
are in there?
Oh, which took 20 minutes. Who'd need your brain? Really good.
Yeah, I'm gonna smoke some sausages tonight. Because it only takes like sausage dish.
There's like 2,
Yeah,
at least. Plus pure with. It's gonna take like 20 minutes.
Not technically.
Bad taste,
Yeah,
Probably tastes bad.
depending on where you live.
Oh my God.
Wait,
That's
what?
your fear dog.
Okay.
I didn't say it.
Is what illegal?
I was referring to illegal.
I really don't want to say it out loud again.
Well, come on.
Hey, push me.
It's gonna be
Gotta say
Jeff Goldblum?
I don't remember how it came out,
Who's what?
but, I'm not gonna say it.
The only podcast I listen to is Joe Rogan. You know that.
Sorry.
I'm just kidding.
Go to Atwood.
Can Alex
No,
say
I'm not really listening to podcasts.
That's not
Oh, that's all right. A little bit. Yeah, you know what?
I think you're the racist.
I can use it with my phone.
No.
I can 100% just
You're talking across the
not have anything going, and I'm fine.
I'll do that. I'll fall into a hole. That's what talking across the internet with the first wall.
That's how you truly live. You just go into your mind.
All right. Any issues with knitting the exam? Hopefully not.
Yeah, mine was with the, my restricted communication.
Yeah.
Didn't have hashtag.
points on my pancake.
Jeff told me to do that, he showed me, it's in the picture.
Okay.
Dude, yeah.
Okay.
I've never had an issue like that with pancake function.
What?
Yeah.
Yeah, I got these.
I'd have to look at it. Maybe it's a different version. I don't know.
I played like 5 times in a row.
HB's, pork Italian sausages. They're cheap too. You know, like with the ground turkey.
A little bit.
The sweet Italian. Those are good.
It's sweet.
Those are my
I haven't
favorite.
had the sweet. I
You
went
know
for
what too bad?
Well, I like the sweet. The spicy's good too.
something that you can eat around a little more sauce.
Oh, yeah? Pretty good.
Maybe they do the carnivore diet. Are you talking about the
lady who keto, bro?
like the 13-year-old?
I'm gonna put it out for 9.
Oh my goodness, no,
It's
you're
like the
using
bunch
almost
of
100,000.
I wear like a
Dude,
bit.
it's not like those guys like her and
Yeah.
the butter.
Yeah, all of it.
That's what she just sounded like. It's not her shit. Yeah, it's like margarine. It's gotta be butter.
It takes long enough.
Yeah.
You can use more.
Most thankful.
Like make eggs in the morning and then use like a half a stick of butter.
Goodness.
That's good.
Your computer's probably like super hot.
That's a change. You know what's crazy? It's like.
What about brown sugar? That's essential.
Yeah, you can say honey. So it's like animal
Let's
based.
save that.
You can say honey because it's everything.
So the opposite of vegetarian or vegan.
It's still, it'll still get hung up, I guarantee you.
Hopefully.
It should be through. Alright. Alright, so let's get going. We got the exam. I haven't checked to make sure that y'all uploaded it. It should still be available to upload. So this is kind of where we left off. This covariate adjusted means. Alright, and I saw it today. Did you see it today? Or Friday? Somebody that was presenting at our meeting talked about these effects. Oh no, it was at the it was on the poster. So if you talk to the person that was talking about motivation and leadership over in psychology, he was reporting these adjusted means. Because that's when you have a continuous variable that's significant and you're looking at the effect of these different factors, what you really need to be doing is accounting for that covariate to figure out what our mean should be. All right? So that all kind of goes back to this type of analysis. We had cabbages. We know that head weight is correlated with vitamin C levels. We need to account for this correlation to figure out what's the effect, how much of an effect does cultivar have on vitamin C? How much of an effect does planting date have on vitamin C levels? All right. Now, when we do our tests, we're doing our post hoc tests, our Tukey's tests, on these covariate adjusted means. To do that, we're going to have to use that GLHT again. All right. So this is, I think, where we left off. So make sure your R markdown's open. Get mine open. Make sure you get your cabbages package loaded again. All right, got my data. I am going to run all of those. Mass. There we go. All right. So we are here. So I had, just kind of as a review, going to view the summary of the mod main. All right, this was our simplified model. All right, we know head weight is a significant covariate, and even if it wasn't significant, I think you can make an argument that we should still include it. It's kind of like including season when looking at, let's say, average lengths of snail in a pond. We know that we're going to get different sizes because the population grows and then turns over and so forth. You know, it might not be significant, but we could still account for it because we know that covariance is there. We know that it's correlated. All right, so this is our model, simplified model. We've got head weight, we've got cultivar, we've got date. That's where we're at. We want to look at date, planting date, to see if that has an effect. So we need to use the multcomp package. So I'm going to go back up to my libraries, add multcomp. I'm going to run it so we can run it. All right, and just as a review, we are interested in looking at tukis. All of our assumptions are met. All right, so we want to know, after we account for head weight and cultivar, what's the relationship with date? Which of those planting dates are different from the rest? So I'm going to create my I'm going to say a mod output. All right, so we are running GLHT, General Linear Hypothesis Test. We're running it on our main effect, our simplest model, all right, where our linear function, linfunct, is a multiple comparisons procedure. That procedure is on date, and we want to run two. I think that is quotes. I do. Put a quote on there. And then I can look at summary of the mod output. Oops. Spell that correctly. So we introduced this GLHT before. In one of the earlier, I think with the ANCOVA we introduced it. Is multcomp and stuff loaded?
The error in factor contrast model.
Okay.
Oh.
Capital D for date. So I could, instead of using summary of the mod main, probably best to use ANCOVA, because the variable that we pass at this spot is the variable that appears in the model. So what it's going to do, what this GLHT is going to do is look at this model and say, what are the variables that are included in the models? I tell it date is what we want to run the tukis HSD on, and then it runs tukis on our covariate adjusted means, or our model adjusted means. It's on the means after we account for the other variables in the model. Entire chunk. So we get this.
Does it matter if there's a red line that says covariate interaction down? Well, might be.
Is your model the main effects only model, or does it include the interaction? Yes, that's not.
No.
Oh, so I should have done that.
So you did your full, right? And then we simplified, right? The major full, we needed to remove that term, right? So then we're going through simplify. Here,
Where are they gonna put their smoker?
People have houses. I think we're a city.
You didn't quite find the main, you
There's no house.
didn't quite find the simplest
It's out of the
model.
forest of the city.
That's what everywhere in New York is either Amish country or New York City. No in between.
That is a great way to describe New York.
I'm just saying, bro.
So we had skip demonstration. Good demonstration. So I'm just gonna go up, you know, as we were working through, we were doing our updates and stuff. Mod full. Then we did mod 1. We took out the three-way interaction. All right. So we got these two-way interactions, right? So I'm going to use mod 1 just as an example. If I tried to run two keys on date, so actually, let's do this.
In that function, did we say that 2e was the date?
What's the date?
Like, date equals 2e, what does that mean?
You're saying that they're two keys on.
Yeah, we're doing two keys on date.
That's, okay.
What we are doing is we're doing a multiple comparison procedure, MCP. All right, and what that MCP is looking for is a variable to create our actual contrast table. So in the GLHT, we've got our model parameters where the linear function, here it is, defines what we're looking for. So when we initially did two keys, it was always two key HSD on the AOV of a model. That model had one variable in it. If it had two variables, two main effects, it worked as well. It only did two keys on the individual variables one by one. With the general linear hypothesis test, it doesn't know what we want to do. So we have to tell it, we want to do two keys. That's why we have two keys in quotations, because we're telling it we want to run the two keys post hoc test. Now, on what variable do we want to run it? We want to run it on date. So that means what this GLHT will do is first calculate your mean adjusted averages. Your mean adjusted averages. That's not the proper term. It is the adjusted means. What was the term that I called it? What was the effects? Covariate adjusted means? Just adjusted means. These. It calculates these adjusted means and then runs a two key on those. We can switch it. We can do two keys on the other variable. But unlike two key HSD, this function will only run it once on whatever variable we tell it to run. And there's a reason, because it has to first calculate these adjusted averages. And then it runs differences on those averages. It calculates your t-statistic, calculates your standard errors in order to generate your t-statistics, and it has degrees of freedom and so forth. So on here, we're going to look at mod 1, which is what we created. Just as a demonstration, you can see, assume we had these interactions, all right, and assume date was significant. I know it's not, all right, but let's just assume for a minute that it is. And you go through and say, okay, I want to run two keys on that one. So we're running it on this model, all right, and the two keys that we're running it on is the date variable here. Right? Doesn't make sense for the cultivar because there's only two levels. So we're going to run it on date. And then I want to view, we'll keep mod output. So when I run it, you're going to get this. Covariate interactions found, default contrast might not be appropriate. That's your warning that says you probably have interaction terms. And if you have interaction terms, it's going to throw things off on doing two keys. Especially if this variable, if this date variable is part of the interaction, which it is. We've got two interactions with it. So there are limitations on when we can run it. But if our variable doesn't or isn't included in any of these interactions, then we could just do something like this, not worry about the errors, and conclude that planting dates, day 21 and 20, have a difference in our covariate adjusted means. And there's no difference in our covariate adjusted means between day 16 and day 20 and between day 16 and day 21.
And scroll up to where we wrote mod 1, they'll have it on
Yeah, we were working through that last week. This was just we stopped ahead of time because what we did was we started with the ANCOVA, which was this part, all right, where we're saying we don't care if this is significant or not, but we know it's a covariate, so we want to include it in the model. And we got to our simplest model. Then what I said was this, which is now we have the question where we have a continuous independent variable. We don't know if it's a covariate or not. So if we don't know if it's a covariate, we started our full model here. And we proceed through the whole model simplification, updating the model and so forth. And what we would end up getting, as we remove these not significant terms, we will get to that point where this mod main is the simplest model. All variables in the model are significant, including heavy. So when you see people say, I ran an ANCOVA, what that meant was they started at this spot. They didn't include the covariate in any of the interactions because they weren't interested in it. All right. Now there's a catch with that ANCOVA. The assumption is that you have equal slopes. And that means that you don't have a significant interaction. But if you don't know if you have one of those or not, you'll arrive at the same answer by starting here and doing the same model simplification that we've been doing. And we stopped. We didn't continue on because we were running out of time. What if we use GL multi? Would we get the same answer? We should. Well, probably. Probably. We should. Did you try it?
What?
Did you try it? All right, so flight. Ooh, flight CSV.
Like, where's that?
That's what we don't. Yeah. Yep. All right, so we're gonna work through flight here. Or I'm gonna let you kind of work through flight. Try to add something.
What?
Is Flight already installed?
No. I don't think so. Flight.csv. There we go. Post it. All right, so as you download Flight, here's the idea, is that you measure the time to flight of moths after scaring them with a model predator. So as Matt was hiding from the tornado, he grabbed a bird, flying the birds around, the bird acted like a predator on a moth that was on there. And meanwhile, we had, let's say, Bethany was hiding in the corner with the stopwatch saying, I wonder how long that thing will fly. All right, something like that. All right, so you scared the moth and then you recorded, once it appeared, how long does it take to respond? For each of these moths, you recorded the sex and coloration pattern on the wings to determine if coloration, meaning if they're spotted, does that alter the time to flight? Again, for like an evolutionary perspective, maybe it's something with camouflage. That camouflage has evolved, a better pattern has evolved, which has allowed the moth to remain still. Hopefully, then the predator kind of overlooks them, because as soon as you move, now that draws the predator's attention. That's the idea. Now, based on previous experiments, we know that wing asymmetry affects a moth's ability to take flight. So you measure the wing size and calculate a symmetry value for each individual. The idea is that if you're at 0, you have perfect symmetry. Anything above 0 represents some form of asymmetry, and as it gets larger, we're more asymmetric. All right, so our real question for this problem is, does sex and pattern affect the time to flight? That's our question. But we know asymmetry will affect flight time. So go through, check assumptions. Let's find the simplest model. Find the simplest model and try to interpret it. All right, so I'll let you go through this. through it. I can stumble maybe a little bit. And then we'll work.
Did we rename mod simple to get the template?
I don't think I did. I left it at mod.main. It's a main effects, but you can. If that's something that you do and you get in the habit of, it's definitely something that you can do. Did yours finish? Did you get that test uploaded? It was, okay, it's still there. Yeah, I can't remember if I cut it off at 5%. As long as you got it up, it's good.
Yeah, I got it. I can't remember what it is. I think it was before 5.
I think it was 5.
Well, that was the due date,
Oh, okay.
but I didn't shut it off
That's the
until,
only reason.
I don't know, 5:30 or 6 maybe.
Okay.
Because I knew if we had questions, we can get it fixed.
Now I can close it.
Hold on. So you saved it, right?
Yes, sir.
And then if you remake it, it should go a whole lot faster.
I'll
Because
just
you use that cache equals true.
Just try it out.
You just realized it was classes.
Yeah. Like, I guess I looked around and was like, wow, it's 5:30.
I guess we found out very cool. Classes.
Not here. You have to say you're cool, you probably don't.
I always say I'm cool.
But maybe is this class taught in psych as well? Pretty much the same.
They're using SPSS, and they will introduce some more stuff. They introduced some stuff that's rough, that like that structural equations model they might present, they probably also do like factors analysis, principal components analysis, because a lot of that is you've collected a bunch of data on like surveys and you need to figure out what are the common themes, what are the common trends. So you're kind of data mining a lot of that stuff. Yeah.
They brought any snails as their examples?
No, probably not. Probably not.
Talking interaction about snails, bro.
You dream about snails now, that you're right?
Against my will, but yeah.
Yeah. It's there. Should we have left symmetry off the main model? Just because we're only asking about sets and patterns?
No,
No.
we have to
it's
account.
symmetry.
We have to account for that correlation.
Okay, okay. Yeah.
Would you pattern times symmetry?
Pattern plus. Symmetry. Right? That is confusing.
No, I got it.
I don't think the times matter, but yeah, I think the covariate is at plus one.
No. I'm moving here, so. We're supposed to simplify, right? Yep, I got that. Too?
Yeah.
Now, I'm in that process. Well, I just feel hard. Is that even possible? I mean,
Yeah. Yeah, I was kind of wondering what you were doing there.
I was thinking.
Y'all have an interaction effect that's good. Yeah, and yeah, it's done then.
What about post hoc test?
Yeah, that's what I said.
We're not. Yeah, we're not, ready for that.
We're gonna sit here and track.
Okay, so-
Right, is it the same thing?
So none of the interaction effects are just a little
Yeah,
bit
how do you
of
do it?
tweaking, then like we need to make subsets.
Yeah, with an interaction. Yeah, we do.
Yeah, but we don't. But yeah, how do we account for the naming the subset? Do we do that in mod outputs? No. That was rare.
Based on previous experience, we also have a possibility.
So. Yeah.
We just find the simplest model.
Yeah, post-hoc test. Yep, I'm working on my post-hoc.
I don't know. What did you base on it? I'm just testing you.
It's really cheaper. Don't want to make that.
It's a spectrum.
So I did find it like one of the interactions. Second time.
They're all.
You been in color.
Oh, would you, oh, I think.
You don't even need.
Yeah. Yeah.
Right, when they're built by we're having the state championship joke cook-off. Joke cook-off. And you get good at your, get good at your color joke. So I'm looking at
Color group, dude, that's like a, probably that's it, one step better. Color group, color group.
Why are you?
I don't get put in now.
I don't know what
Hey, are you doing your, like the covariate? Okay. That's what I'm doing. Kind of just stumbling around until I'm describing my entire life to.
How'd you do it on the exam? When you had a significant interaction?
Stumble across or something.
I subsetted it, made a linear model of my subsets, and I did it with that.
Okay, what if you had other terms that were not part of the interaction? How did you handle those in all your post-hoc tests? Yeah, but let's say you had two main effects, and you're interested in two keys on one of them. What did you just drop the term?
You can whichever one had more significant.
If they're both significant in your simplest model.
With, are you talking about when there's an interaction?
Yeah, so let's say you had a main effect and then you had an interaction. So you had, I don't know, variable A was significant and then variables B and C had a significant interaction. So you took your subsets, right, for variables B and C. What did you do with variable A?
I did your answer.
I know, but when you took your subsets and did the analysis on the subsets, what happened to variable A?
Oh, that probably went. I probably should have.
I'm not sure.
Or you dropped it? And if it's in your simplest model, it stays in your simplest model. It'll always stay in your simplest model. Right? How did you look at it? I mean, I explained that in the keys. And I laid it out in the homework keys too, every time. Your simplest model, significant, it needs to stay in there. So the analysis doesn't change just because the variable is significant, is a continuous variable. If symmetry is a covariate, it needs to be in the model, it needs to be in all models that get created. Even when you take subsets, it has to stay in. So let's go through this.
Is that also true of interaction effects, if they're significant?
Yeah, so if the interaction is, if you've got a lot of variables and one of them has interactions and you're analyzing some other variable, that interaction still needs to stay there. So let's start here. All right, so flight.csv. All right, we have symmetry, pattern, and sex. And we know that it's associated, so I could analyze it as an ANCOVA, all right, analysis of covariance, multiple factors, but I'm gonna include it. I'm gonna say, let's check to see if it's significant first. All right, so I make this full model with all of our interactions. I look at my GVLMA, assumptions are met, and just to kind of demonstrate, we could also look at our residuals. So this looks good. This one, yeah, it looks pretty good. If I was really curious, I could extract the residuals and use QQplot to get those error bars on there. But yeah, I mean, GVLMA said it looks good. I think I'm going to go with it. Scale location looks good. I mean, it's not increasing or decreasing. Residuals, we do have one that's down here, 3. So if we wanted to go that next step, after we do our analysis, we could drop number 3, row 3, and rerun it to see if we get the same answer. All right, but we're not gonna do that. So I've got my full model. Model simplification, we could do one of 2 things, and maybe we could do both. One is to start with our ANOVA tables. That's not significant. The 3-way interaction is not significant, so we drop it, and we just keep dropping terms until we get to the significant, or to the most parsimonious model. The other one is to go through and use GL multi. Now, in theory, we should converge. And if you look at a difference, if you get a difference in what the ANOVA tables give you and what your GL multi gives you, a lot of times it comes down to the weight table and the values of the AICC or the AIC, whatever you use. So if you get, let's say, 2 different simplest models, this first one was pattern, sex, symmetry, and sex pattern. So pattern and then sex and symmetry interaction. All right, that was one. If we add, maybe our second model was this one, this pattern and symmetry. Maybe ANOVA gave that as, hey, we need to include it. When you look at it, you can see that the AICs are within 2. So AIC really can't resolve it. And then you just kind of have to make a decision. Am I going to include do that more complex model, or am I going to analyze the simpler model? All right, in some cases, it'll be like right on 2, or pretty darn close. But here, coupled with our plot, all right, the next closest thing was 40% of our models had that. And we said, kind of at the 40% mark, anything less than 40, and this looks like it's less than 40 if I can eyeball it. I'd say pattern symmetry is not significant. So symmetry, sex pattern, and the sex pattern interaction, those are our significant terms. Those are the terms that are in our simplest model. So I did that. I created mod.simp. That's what I'm going to use. That's what we're analyzing. All right, so one thing I could do is look at mod.simp, and I'm not really interested in the variables, in sex, pattern, spotted, or sex, and this pattern. Right? I'm not really interested. What I'm interested in the symmetry, and what the symmetry is telling me is that as my symmetry value, as asymmetry increases, my time to flight decreases. That's our covariate. That's the effect. Now, we have to account for lists as we investigate our interaction terms. So you're right, we have a significant interaction, so we're going to create subsets. So I'm going to start with our sex. So I created a male and female subsets. So male moths are one, female moths are the other. And then I'm going to start with the males, because that's the first one that I made, and create my model. And this is the model that I created. Why was it this one? Well, it's because we're interested in pattern. we've corrected for sex, or we've adjusted for sex or controlled for sex by taking our subset. So now, once across our male moths, is pattern still significant? We have to include symmetry because it's part of our main model. It's part of our simplified model. So our model is this. Time is a function of symmetry plus pattern. Create it. We look at our ANOVA table. All right, and this tells me pattern is significant. Now, if pattern was a 3, let's say 3 levels, 4 levels, we have to take it that next step and probably run a Tukey's on that. All right, and we would have to use the GLHT function to do that, so we're looking at covariate adjusted means. But with pattern only being 2 levels, spotted or solid, this is sufficient. We can look at the covariate adjusted means to make our conclusion. So, what is it? Effects, mod.m, and the effects that we're looking at is pattern. No, I think I've got it reversed. Try that again. Effect. Extra S. Effect. So we know they're different, so we can say solid after adjusting for the asymmetry, after adjusting for that covariate, solid moths took longer to fly in response to a predator. All right, so that's for the males. That's for male moths. We repeat for female moths. Female moths, also significant. So now we can look at the effect of that. And now in the female moth, we see the effect of some of our interactions. So in the females, actually the spotted moths are the ones that take longer. And this difference, this covariate adjusted mean is different. So solid took 16.6 seconds, milliseconds to fly, probably milliseconds. Spotted took 18.4. They were slightly delayed. And this is after we account for the differences in asymmetry. So that's pattern, and then we repeat it with our solid and the spotted. We take our subsets, all right, and we start with within our solid moths. So within solid moths, what's the effective sex, or is sex significant? Again, we have to include this term because it's in our simplest model. We're not analyzing it, but we have to include it so we can account for it. So with our solid moths, we have a difference in the flight time across the sexes, and when we look at them, clear difference. What's that?
Sorry, I'm just really behind.
So we're at
Going there first. Yeah, I'm trying to catch up to your script.
So we got our simplest model, and we've done this. Just this is a continuous variable. It didn't change what we do just because it's continuous. In terms of our post hoc test, we still include it. Instead of looking at averages, though, we're gonna have, if we're interested in covariate adjusted means, we're gonna have to use the effect to get those. What's that?
I didn't get the same numbers as you. For whichever your pattern effect is right below your cursor.
This one? So you made your females?
Right. Yes.
All right, so let's look at your ANOVA table.
I got the same stuff from males and females.
Well, that's not the same at all either.
did you make your subsets?
If I pattern is different.
Yes.
What do you mean?
Mine's equal.
Well,
What do you mean your patterns?
see, but the value was still less than 05, but it.
Yeah.
I have 1003 is variance.
No, we didn't randomize it.
Oh,
We had the same data set.
Are you looking at?
So which one are you looking
Well, I
at?
have the wrong another table.
well,
So for the males, so get the ANOVA table. So here's our ANOVA table. That's probably what it is, 0.0036.
yeah, I'm sorry, I was just looking for all. You're right. Which one was the one before that?
The females, I believe.
Oh, yep. Sorry about that.
So you got symmetry. So then when you look at the effect, now you get the effect size. I mean, it's significant, not a whole lot, but say 1 millisecond difference, 0.003, could be a consequence of large sample size. I think females is where you get the real big difference.
Going to?
Yeah, where is it? Where did you create it? This is the error message. Columbia factor. So you already did your spotted right for pattern. Why is pattern controlling?
Error message. Contrast can only be applied to practice with 2 or more levels.
Yep.
Try set.
On my
Try
dot
putting
spot.
No, because we controlled.
Plus X. That's exactly what I did.
Okay, I'm sorry.
I mean, you're making sense.
You put checks on his, I don't know what's going on.
Reload your data file and then run your subset at the end.
Reload my data file.
Yep.
Like fly.csv?
Yep.
I wonder if I'd be more happy.
I don't want to blame all my problems. Yeah. How many little months ago you still use Microsoft Edge?
No, it could have been something if you didn't,
Yeah, put it down.
if you overwrote a variable or something like that.
Well, I didn't know that. Nothing I'm talking
So do anything for violence?
No, I didn't go out.
Okay,
Was it this weekend?
I think it was last weekend.
It was.
No pitching turtles with violet?
No.
Any snake?
No,
about.
we had coaches yesterday, but not.
What's that?
We have a final as well. Okay, thank you.
Is it
That's the
cute?
thing, but I.
Is it cumulative?
It's cumulative.
So the Blackboard will be much more thorough on, as it goes back to like variable names, variable types.
Like the theoretical part?
Yeah, choosing tests. Simplify. No, we do add correlation. Alright, and this stuff doesn't necessarily change. Maybe like what covariate just. But from here on out, we're just simplifying how do we handle these variables.
Okay.
Do you get it?
I got the same area and I reloaded it.
Solid work?
Yeah, looks like.
What do you want to solid?
And you didn't run a sexy pattern in the
Please. I did, yeah.
Oh.
Yeah, I think that's up there.
Pattern should be small.
Yeah.
Oh, wow, fine. Here I am. Sorry. Been a long.
empty.
Huh?
I didn't have to go to the lounge because
Because
your group succeeded.
Oh.
That's fine.
Oh,
Yeah,
What do we have to do now? We all gotta write a lab report too.
Yeah.
That runs it. Runs the line.
Oh, really?
Yep.
Okay.
Right.
Option enter runs just that line, does command enter run the whole chunk?
No, command run just runs the line.
Pretty sure. If it's due tomorrow, yeah.
Oh, right.
Yeah, I know, I was just thinking.
All right, so we run through our solids now. Hopefully, I think everyone's kind of getting it. Nothing has really changed. Just, again, we have this extra variable. It's a continuous variable. And when it's continuous, the analysis is looking at the effect. It's looking at the covariate adjusted mean. So when we do our solid subsets, oops, in open table, all right, we get a significant effective sex, and the effect size, after we account for symmetry, you can see the females take quite a bit longer, say, 5 milliseconds more to take flight than the males. And again, this is after we count for sex, and that's for the solid. For the spotted, we also have a significant effect of sex. Where the females also take longer. All right, so our so if we were to kind of go through and plot it, I color coded it and I used open and closed symbols. Makes it a little bit easier to kind of visualize differences in our pattern, differences in our sex. Do I have the code up here? Don't have the code. So I basically keyed it in. So solid, I think, is solid. Let's see here. I don't know which one it is. Yeah, one of them. Oh, that's here.
It's like male, female.
Yeah, I can't remember which one's solid and open and which one's.
Females are probably the dark ones. Solid ones?
Spotted.
Yeah, spotted might be the dark ones because they look like a little spot. The open ones are solid.
Yeah, I'm thinking there's alphabetical order in how I keyed this. I didn't include the script for that. But we can color code and use different symbols. But you can see the pattern. So our symmetry, here's our relationship. All right? And when we look at our differences, you can see that the black spots are definitely higher than the red spots. That's one of our effects. If we were looking at closed versus open symbols, now you're looking at there's an interaction on how we look at it. The solid and open seem to be grouped pretty close together here, but when we get down to the other end, it looks like we probably have more solid circles right down there relative to the open circles. So solid and open may have been the difference between male, female, and red and black may have been solid versus spotted.
There's some way you can make a key so that you know what each little icon is.
Mm-hmm.
That would be helpful.
Let's see if we can actually make it because we're running out of time. So here's a plot, and I can't believe I didn't include it. Let me open it up. Maybe that slide is hidden. Maybe the slide is hidden. Because I have typically included graphs. Now I didn't. So let's go through it. So this is a scatter plot. We're doing plot as a function of, let's see here. We're plotting time as a function of symmetry. All right, and if we just do a scatter plot, this is what we get. All right, so we're going to have to color code, and we're going to have to symbolize it. All right, so one thing that I'll start with is color. All right, so for the colors, we have to figure out how we're going to do it. Colors equal let's just try sex. There it is. Color equals sex. There it is, red and black. Black are the females, red are the males, because it's alphabetical order. So what happened, all right, our data frame, here's our flight data frame, all right, is in M and F, all right, male and female. So when I pass that to our color part, it's going to look at it and say, well, that's not a color. So what it's going to look at is how many levels, how many levels are there in this column. All right, it's going to see there's an F and an M, and then it'll key it as color number 1 is whatever comes first alphabetically. Color number 2 is whatever comes second. What are the colors? Anyone remember how to do our colors? So we can do colors this way, but that lists like all of the different colors that are available to us. But this isn't what we're looking at. Instead, what we're looking at is palette. The palette gives us the colors. So color 1 that gets used is black. The next one is this, which should be a red. I think on my computer, it used to actually give the numbers or give the actual words. So it was black and red and I think light blue and then green and so forth. So we can kind of fix the palettes by doing something like this. I'm going to say color 1. I'm going to call it COL1 just to get the list of colors. All right, so that's what I have. So I'm going to replace it. I want black. The second item I want is red. All right, and let's say the third item I want is, I don't know, blue. That'll work. All right, so now if I look at this, I've got black. Oops, hold on. 0. Oh, because I didn't run it. No wonder. 3, 2, 3, color 1. Now I got black, red, and blue. So in order, I'm going to use black, then red, then blue. All right. How do I get this back into the palette? Palette. Oops. Color 1. Oops. Should work. Palette, color 1. Now if I look at my palette, let's see if it fix it. All right, fix this. Right? Right? How about we do it this way? How about we do this?
Should be easy.
Palette 2, palette 3. And then if I use palette, there. Oh, no. Something's up. I did run that, right?
Why would palettes be the one that you don't know though? Like just define everything within color one.
Oh,
We usually define palette first.
No, palette is already built in.
Yeah, well, I'm saying like, if you just run color one, color everything. But is it because of that first bottom tone where you color one?
Yeah, color one, I was just saving it to
Yeah.
figure out how many I had, what I wanted to choose. That's what we're doing. And I don't know, maybe it's, I'll have to look at how to change that palette. Can't remember, but that's what it works. So color, it did it fixed. If we tried to do it differently, so we could pass it an actual vector of black and red, all right? But it's just going to alternate black and red. So row 1, point 1 gets black, point 2 gets red. There's no standard, so we have to have some way to match the color with the label. And probably the easiest way is just to pass the variable and say, this is what we're looking at. If we wanted to shift it, maybe we didn't like the black and red, maybe I'm going to shift it one color over. Oops. That's not going to work. I'll look up and I'll show you how we can get these palettes fixed. All right, so once we have that, then legend T, no, not a graphical parameter. We have to manually put in our legend. All right, manually put our legend in, which is what you asked. So we've got our figure. I'm going to give it a legend, and we have to tell it where we're going to put it. So I'm going to look at the graph and say, well, I think x equals 4 looks good, and maybe y equals 25. All right, so I'm going to do x equals 4, y equals 25. All right, and then I have to give it what we're reporting. All right, so I'm going to report female and male. That's what our legend is. And the color, let's see if we get color and flight sex. Oops, hold on. Plot. We may have to manually call it. Why? Plot.new has not been called. There it is. I had to run the chunk together. I can't run it individually. So the color didn't quite work. We'll have to do red, black, and red. Oh, and PCH. I don't know. 21 might be open. 21 is open. And we can move it. And perhaps we don't like this. Perhaps I want it shifted over a little bit more. I'm just going to have to keep, remaking it. And here's the problem. And this will kind of be why I said the whole graphics could be an entire semester. We need to get this picture out as, let's say, a JPEG so that we can embed it into a thesis or embed it onto a poster or something like that. All right. If I copy and paste it'll ask me, how do I want, how big do I want to save it? When it scales, the scaling factors for our axis, labels, our titles, numbers, even the legend will scale differently. So this looks great, and we could be happy and say, hey, I want it perfectly like this, but as soon as you export it to a JPEG, it could be completely different. So what I typically have is I've got, let's say, Microsoft Paint or whatever the picture is. On Linux, it's just an image viewer. I export to a JPEG, and then I immediately open up that image and say, what do I need to do to fix it? And then I have to update the code, re-export it, and it's just a process over and over and over again until I get the image that I like. As we add the colors, PCH could work the same way, but I don't think it will because our patterns are going to follow patterns 1, 2, 3, and 4, and it's not going to start with our open circles. So that's where we kind of run into some problems with trying to come up with it. So what I'll do is I'll make this graph here again. I'll get it to where I like it. I'll add a legend, and then we'll get the script so you can see how I did it, how it works. Again, kind of just serves as FYI information if you ever need it. And if you do need it for a poster, come talk to me. We'll get it working. All right.
You can take your time there when you start that.
No, the plan is to look through those in the morning and try to get done.
Yeah.
We just focused on the in conclusion part, right?
Oh, the
Yeah,
rest.
as long as we got the right.
Yeah.
All right, that's all that matters. I'll take this one. Would be it. If I wasn't so burnt out on molecular concern, happiness has got turned in.